is Luca Weiss and kernel support for mobile Linux.
Hi. Yeah, thanks for coming. I'm here to talk about the missing 20% of kernel support for mobile Linux. Yeah, my name is Luca Weiss. I'm a Postmarketer's core contributor. I've also had many patches in the Linux kernel already. Not really in the core kernel subsystems, but more on device bring-up and a few drivers and things. I'm maintaining the OpenRaiser project, and my day job is in the software longevity team at Fairphone. So, if we look at how mobile Linux is currently looking in 2025, this is the list of devices in Postmarketers in the community, or phones in this year. You can see green, it's working, orange, it's partial, like sometimes it's working or a part of it is working. And the white or gray is, like the gray is not available, but the white parts are not, it's not working yet. So like you can see, like there's quite a good number of devices which are quite well supported already. But no device also is like completely green, or like you don't see a sea of green, unfortunately. Let's go a bit back in history. So like if we look at, 2016, for example, you can see there were basically only 3 devices in mainland Linux, which were ARM boards. By the way, I'm mostly focusing here on Qualcomm devices because that's what I'm familiar with, and it's also what most devices are used, or like most devices in mainland are based on a Qualcomm chip, even though there's also some MediaTek devices and some other ones. But back in 2016, there was basically only the Nexus 7, which is a tablet, also not a phone, Sony Xperia Z and Sony Xperia Z1, which were like the only actual form factor devices that there were. There was a bunch of like single board computers and some test devices, but nothing, apart from these 3, nothing really good. And for ARM64, there was actually no single phone or tablet or something in there. In August 2016, one of the devices that for the longest time was like the device with mainline support, which was the Nexus 5. It got added in August 2016. And there was also actually a pretty cool demo of the Nexus 7 tablet running with the FreeDrano open source graphics driver, running Android, but like from a kernel perspective, that was working back then. And in 2017, Postmarketer started as basically the first Linux distribution made for mobile phones. Also back then only 2 phones were supported with 3.0 and 3.4 kernel, respectively, not mainland at all. So and it was using the Western compositor, which is just a reference for the most part, and some demo apps for like GTK3 demo, so you can open like the widgets demo. So it was really not super interesting, not at all at what you would expect from a phone. But also nowadays, already like there's a lot more devices supported. Obviously, it's like with 34 devices for 32-bit Qualcomm, and there are not too many are being added because no new devices being launched with 32-bit. But 64-bit, we already have about 140 devices there. And I excluded some, like Chromebooks where there's like 10 different variants of it. And there's also quite a few more devices out of 3, so not in mainland yet. Quite a few of these devices can actually be used to some degree for daily driving. So I mean, maybe just as a podcasting machine, so you download your podcasts, you stream them to your Bluetooth headphones, or as a YouTube machine, so you just have the browser open with YouTube. So like for these purposes, it's actually working quite well nowadays even. And also this talk is mostly focusing about the kernel. The user space parts are living on top of the kernel, so like if the kernel doesn't work, user space also won't work for this feature, for example, camera. So like mainline sort of works for these devices. So if we look at the whole device bring up, there's basically 2 different important topics. There's functionality, it's like whether a given feature works or works when you test it, and about reliability is about does it actually also work like the 5th time opening? Does audio still work after being suspended for 2 hours? Does camera switching work all the time and not get stuck randomly and then needing to reboot? So like device bring up, what most people are doing is just really looking at functionality and is not really testing reliability. But then reliability is really what the people that try to use the phone actually notice and see. And this is what they get annoyed about if it doesn't work. Like if you want to use your camera and to make a photo and then it doesn't work because, I don't know, there's some issue somewhere, then yeah, then they will get annoyed probably and not like using the phone as a daily driver at least. Yeah, and yeah, what you always, or what you often hear is like, I just want working phone calls, please. This is kind of the most difficult because it requires so many different components to work together, and also together with Suspend and maybe this voice over LTE coming at some point. And there's a lot of things to that need to actually work properly there and need a lot of extra work to make this work properly. And yeah, also like I will talk a bit about this a bit later, but yeah, like we also need to figure out like what we want to achieve, like how we want to organize and make, for example, like one specific phone work very well or something. So right now it's kind of a bit the Wild West, so like everybody does what they want to do, and it's really cool. But of course, then not a single device is then actually getting well supported by doing this. So yeah, let's look at the kind of the 20% of functionality that are missing. So I would say like for a lot of devices, like what you saw earlier with the green and orange checkboxes, like more than 80% is actually working for quite a lot of devices, so it's really good. But it's also, yeah, there's some things missing which are missing for a lot of devices. So, I mean, display is working for basically all devices which are any usable. But for example, cameras is still quite a topic where not a lot is supported right now. But it's actually like in the last year, a lot of devices have gained camera support. So Pixel 3a. I've also got 2 cameras working on the Fairphone 5, so lots of things there. There's some devices where the battery fuel gauge driver is missing or not working properly. This is where you can see the battery percentage on your phone then. And then yeah, phone calls is kind of a difficult topic because yeah, there's so many edge cases and so many reliability things that that sometimes not work. But yeah, also like it's always kind of a different set of functionality that's not working for any given device. So like probably if you take some from this device and some from this device, you probably have like a fully working device like split across 3 phones, which is also not very useful. And yeah, the bring up for new devices, like for new Qualcomm devices, is actually surprisingly trivial compared to like the like devices from, I don't know, 5 to 8 years ago. Because the SoCs are already, there's a lot of functionality upstream already, and most SoCs from Qualcomm are only quite a minor variation from each other. So while there might be some bigger difference in the marketing from the SoC manufacturers, they are quite similar, to be fair. And yeah, and I would say like if you start from scratch for a completely unsupported SoC in mainline, at least after like I don't know, after at most a day, you can have the device booting to something, so that you can have a shell on it. And after I don't know, a couple of days or something, maybe a week of full-time work or like a couple of weeks of like hacking on in the evening, I think you can actually have a device working reasonably well, unless you hit some roadblock which you don't know how to resolve, which is a different problem. There's also the problem that getting some functionality in the kernel upstream can be quite difficult for certain things. So for example, for cameras are a good example, because cameras are quite complex. There's normally no public documentation. Even if the data sheets available, they're often not complete or not very useful, to be fair. And there's a lot of kind of magic variables that people who are not super familiar with how cameras or the communication works can be quite difficult to then make a let's say proper driver that actually handles the things correctly. It's also the case for both Fairphone 4 and 5. There's a vibration motor driver in there that is quite complex for what it should do. And there also the documentation is basically non-existent. It's difficult to get. I mean, for me, working at Fairphone, getting through our ODM then to the actual supplier is quite difficult. And since we don't have any documentations, it's tricky to know like which part should be configured how exactly. Yeah, so like things are there. Things like this are difficult. There's also, for example, audio amplifier drivers. Often you can just copy paste a downstream driver and it works. But then actually getting this into an upstreamable state is a lot of work, and they're just also often the you don't really want to take the time to do it. You don't want to spend a week rewriting a driver which was really bad in the first place to try to get it to some state to be able to upstream it, because it's not too much work to rebase those. Like normally, like every couple of releases, you need to change a few lines. At most, maybe if the return type of the remove function has changed from int to void, then you need to change this. But otherwise, it's not really extra work to maintain this out of tree. And for basically all devices, there will be a need for some patches on top of mainline kernel in any case. So it's not like you can completely get away from doing this. Yes. So let's talk about reliability. So we were talking about functionality, if it works, and now reliability about, if it actually works all the time when you want to use it. So when somebody's working on bring up, they're working on functionality. They look at, I don't know, does the touchscreen driver work? Does it recognize touches? It's a different question, like whether the touchscreen also works correctly when you have your gloves on, where it might need some extra code in there or something. Or if it sometimes misses something, or if the camera driver works all the time. So there's a lot of different things there. And reliability is very often just ignored during this stage because it works well enough for now, essentially. And yeah, developers like me, like I don't actually use the device like as a daily driver. I boot it up, test one thing that I'm currently testing, and then reboot again to test an updated version of the same thing. So I don't have the device running for multiple hours and then seeing like what things still work correctly, for example. And I don't update every day and then see exactly if anything has changed or if anything is broken and then try to fix it. So I'm not quite sure like how to resolve this like community-wide. Basically you probably the developers, like if there's only one person, they need to start actually using the device, and then figure out what things are actually not working correctly, etc. But yeah, it's just a lot of work, especially if it's only one person doing this all the time, because there's a new kernel release every 9 weeks or something. There's new stable release for stable kernels every week or something, and obviously if you run a rolling release distribution, then packages change every 10 minutes essentially. It's like making sure it actually continues working all the time is quite a lot of work. And especially if you have multiple devices in the same SoC that you're supporting, then you should probably test all of these devices. So yeah, you really need to be very persistent there in doing this. And but of course, and also like if after a few months you kind of get bored of it essentially, then yeah, nobody's doing this anymore, which is also not great. So now I'm talking about what we need, and like I defined here as kind of a group wanting to get like one device working perfectly well. So it's usable by your grandma, or at least your sister. And like it doesn't matter which device in particular we are talking about, like just any device. And also like even if we just want techies to use the device, so actually have like their Linux command line and everything there, like we still need to have it working reliably and well, everything that we have. So I think to achieve this, like actually multiple different people or multiple people with different roles need to kind of come together and focus on this one thing. So like kernel developers need to kind of sit together and also just brainstorm sometimes to how to resolve some issues where one person can just be stuck and just not not really have any good ideas on like how to continue or how to debug the problem to resolve it. For example, getting the video decoder to work on some SoC. Yeah. Then there needs to be just some testers that actually just look at it, or just make sure that new releases, be it stable cars, so very minor version upgrades or actually major version upgrades, to make sure these actually still work correctly, and this person maybe then also uses the device for a bit longer, for example, I don't know, watch some YouTube videos and sees if this works. And maybe some sort of project manager which kind of tries to hold it together, try to keep it on track, try to maybe advise on like what is the best thing to work on now. For example, if there's 5 features not working, and then like which one is the most important for our target audience, essentially. And yeah, what I mentioned before, I don't think a single person can do everything at once, because there's just not enough time in the day to do this. And also for people who like to get started with kernel development or also testing, like I think any person who knows a bit of Git can already get started with merging stable updates to the existing branch. So for example, from 6.12 merge the 6.12.3 tag into it, make sure it builds, which it normally does, and then briefly test it or test it a bit further. And I think anybody with some Git experience or willing to learn Git at the very least can do this. And even a step further than like rebasing the kernel on a new version or a new release candidate from the kernel, it's actually not too difficult. You need to know Git rebase, but it's for the most part it. And of course, if then something fails, you can ask someone who might want to help you. But for just getting started with it, it's not necessary to be a big kernel developer or something to do this. And I think it's also really important to motivate each other in the whole thing. And like, if also the developers know that people are actually using it and are basically appreciating what you do, it is already helping to keep people motivated. Because if you don't see anybody actually using it, it's like at some point you think like, why do I actually do this? Why do I spend so much time on this if there doesn't seem to be anybody interested in it? But if there's somebody coming along who looks very interested in it, then I think it can be quite motivating in my experience. And so we've looked at what happened in the last 5 to 10 years, which is everything that you see on phones now or on post marketers nowadays has happened only in the last 5 to 10 years. Before there was nothing. So I think in the next 5 years there will really be a lot of progress. And maybe we're 80% of the way there, but it will take at least another 5 to 10 years probably to make the other 80% to work. I think it will definitely become better, but we need to keep working it and make sure to press along. And we're getting closer every day, essentially. Thank you. Questions?
One thing you didn't mention was device tree source.
Mm-hmm.
In order to support mainlines of device, you need device tree.
Yeah. So for the device tree source for porting mainline. Yeah. So I mean, for devices where this is not provided by the not provided in the downstream kernel sources, you can essentially just decompile the DTB that's running on, like the binary that's running on the device on the downstream kernel, and just work from that.
That's not source.
It's not source, but you can still work on that. That's no issue. I've tried this for some random Xiaomi smart clock, and there's no kernel sources at all. I've asked Xiaomi about it. The customer support basically said no. But you don't really need it strictly. I mean, yes, downstream kernel sources are, for most extents and purposes, very needed. But for the DTB, you can decompile it, essentially. But you can ask me later. Yeah?
Are there any resources on, for example, how to hack the cameras, which are often not working, or because navigating the Linux kernel is quite overwhelming,
Mm.
at least for me. So I would need some pointers to help. And is there anything available currently?
Yeah, so the question is if there's any resources for getting cameras working. And I think right now it is quite limited. There's essentially, I mean, you can look at existing camera drivers or camera sensor drivers and kind of see the structure. For the most part, it is an init sequence of register writes that gets written to the device, and then basically 1 or 2 registers to start streaming and stop streaming.
Ah.
And that's it for the most part. And you can essentially dump this from the downstream kernel, just see like what init sequence it's writing to the device, add some prints there, and then start from that. In the base case, then you get a camera stream also with the same sequence on mainline, and you get a camera stream. If you just get a hang while reading the image data, then there's something wrong, which is in the fun part, which I also don't know how to really debug yet. No more time for questions, but yeah, I think I will be maybe outside, so you can ask me then. Thank you.